In 1828, a German federate state named Bundesland saw a man who was about to turn the entire world of chemistry on its head. Good morning, Mr. Waller. What are you working on? Hey, remember how my wife told me I'm no longer able to show my love to her? Well, I'm going to synthesize a compound that will make me the king of Romulan. But sir, aren't inorganic compounds dangerous? They'll kill you. Only if I die. Cheers! That's what killing you means. Also, I'll make a brand new organic compound so I don't die. But for that, you'll need a vital force. Where will you get that from? Oh, who told you that? Zaltan? He's just a messed up guy thinking atoms are real and whatnot. Ah, look like it's ready. I made it. It smells like urine, so. Also, Romulan doesn't exist. Ouch. Friedrich Waller was the first person to synthesize an organic compound. He made urea by converting ammonium cyanide via a process now known as Waller synthesis. Since then, scientists had an entire new field of chemistry to study and discover. In this series, we shall learn the basics of organic chemistry from the ground up. Before learning that, let's take a look at how atoms combine to form molecules. Oh boy. Atoms are made up of protons, neutrons, and electrons. The protons and neutrons form a nucleus while the electrons revolve around in specific orbits. These orbits can have a maximum number of electrons, and atoms tend to search for or lose electrons to match that maximum number. Oh, nucleus, I hope we stay together forever. Yeah, about that. What do you mean? Um, Chlorine came over to me and asked if he could take you for a while, and I kinda said yes. Oh no, at least I'll only be separated from you for a while. Yeah, by a while, I meant forever. What? Yeah, I don't need you. Okay, bye. Atoms want to keep their valence electrons to themselves, but how strongly they can keep them depends on the desire. This property is known as electronegativity. As we saw, sodium didn't care much of giving away its electron, so it has a low electronegativity. Meanwhile, chlorine wanted to gain an extra electron, so it has a high electronegativity. Elements from the right side of the periodic table have high electronegativities like fluorine, nitrogen, oxygen, etc. Meanwhile, elements from the left side of the periodic table have low electronegativities like sodium, potassium, calcium, etc. In general, electronegativity decreases as we go from right to left and top to bottom. Hey calcium, listen. So you know I got 6 electrons, right? If I could get 2 electrons, I'd complete my octet and be so happy. Is there any way you can help me? Well, I got some extra electrons, but I'd really like to keep them. I like being an octet, but giving them out is a lot of work. Yeah, I get that. How many do you got? I got 2 extra. Huh, well, that's exactly what I need. Yeah, I know, but I don't want to give them. Yes, I know that, but if you just hear me out on this one, what if I took them anyway? What, what, what do you mean? Those are mine, though. Yeah, but you see, I am much more powerful than you in terms of electronegativity, so I can take them, and there's nothing you can do to stop me. Oh no. Well, at least can I stay close by so I can see how well they are doing? If you're willing to not put a fight up for it, I guess I'll allow it. And that is basically how compounds are formed. This type of compound is known as an ionic compound or electrovalent compound. These are formed when the atoms are willing to completely give and take electrons because the difference in their electronegativity is quite high. But when the difference between the electronegativity is low, these atoms tend to fight back. Hey man, listen, I need one electron to complete a duplet. Why do you need to complete a duplet while the rest of us are trying to complete octets? It's not your concern. Can you help me? I do have 4 extra electrons. I'm not willing to give up mine, so how about this? You get 3 others like you, and all 4 of you give me your single electron, and be alone. What? No, why would we do that? How about we just take one from you and run away? I'd like to see you try. Ah, what the hell are you doing? Leave my electron alone, you maniac. Hey man, I said I wanted it. Okay, listen, it looks like none of us can overpower each other and take away each other's stuff. How about we just share our electrons and be good guys? And good girls. You have a very weird voice for a girl. This type of bonds, where atoms share their electrons instead of giving or taking them whole, is called covalent bonds, and the compound formed from these bonds are called covalent compounds. But this sharing is not always equal. Well, it's mostly not equal because even if the gap of power of atoms is small, there is still a difference, and the stronger elements tend to pull the electrons more strongly. You can imagine a covalent bond as a tug of war for electrons where the element with the higher electronegativity is stronger. This uneven distribution of electrons in a bond generates a small electric field called a dipole moment. The dipole moment of a molecule plays a major role in determining the physical properties of a compound. The covalent molecules that have a dipole moment are called polar molecules.